Assalamu alaikum. Hello, welcome back. Today we're going to study one of the very important concept in chemical bonding, that is atomic orbital hybridization. Let's just start. The concepts like Wasif theory. Actually, we're not going to start straight away. What is actually atomic orbital hybridization? Firstly, we should know that why is the need uh, of this concept. Why do we need to explain the structure of molecules on the basis of this hybridization concept? So let's just come to know that why is there need. Alright, the concepts like Wasif theory, valence shell electron pair repulsion theory, and VBT, that is valence bond theory, which are good enough to explain the molecules, the bonding in the molecule and the structure of the molecules. But there is a little problem with these concepts, because that is and this actually these concepts just explain the structure of molecules on the basis of unmodified orbitals. Now, what are unmodified orbitals? For this we need to know what are modified orbitals. So actually we will discuss during this lecture what are actually modified orbitals. Okay, the unmodified orbitals are the orbitals which do not undergo any change before bonding, and they take part in the bonding in their as such form, in their as such natural form. So let's see what are the problems offered by these. What our problems are eliminated by the atomic orbital hybridization concept. The problems offered by these concept actually. For example, see the molecules, a few molecules like the molecules of carbon. Molecules of carbon. We know that carbon is a number one tetravalent atom, and number two its atomic number, that is Z, is 6. So by tetravalency, by tetravalent we mean that carbon can make 6 bonds. I'm sorry, it can make 4 bonds. But when we look at the atomic number of carbon, it is actually 6. And well, let me just write on its configuration. Electronic configuration of carbon, it is it has 2 electrons in its first shell, and it is 2 as 2 electrons, and similarly 2p and 2p. 2 electrons here and 2 here, and 1 electron should be here, and similarly 1 should be here. You can see that in the 2p Z orbital. So this is the valence shell of carbon, and you can see there are 2 paired electrons, and similarly 2 unpaired electrons. Right, these are unpaired electrons, and we know that only those orbitals take part in bonding which have unpaired electrons. So we can see here in this state, that is actually this is the state of carbon. Carbon has only 2 unpaired electrons, so it should make only 2 bonds. But already know that we already said that the carbon is tetravalent. So if it is tetravalent most of its in its molecule, then it should make four bonds, but from here where we can see that it should make two bonds. That the Oliver element atoms do undergo jumping of electron, and the carbon in a similar way carbon can do that also. So when this happens with the carbon 6, when it is in an excited state, that is electron can jump from one of his orbitals to a higher orbital, like this, as 2s, 2p x, 2p y, and 2p z. One of the two electron can jump from here and get excited and get into the 2pz orbital. This is what we call the chiral electron get excited, and in this way we get four unpaired electrons. Okay, doing this we can understand how can carbon make four bonds, but there is still one problem. Still one problem exists, and that is actually, okay, we know that the electron has jumped from this 2s orbital into this 2pz orbital, and by doing this we have now four unpaired electrons. Now the carbon can make four bonds, but there is still one problem. We know that the four bonds of carbon are equivalent, and that is they all have equivalent. They are all equivalent in energy. And how can this happen? If one of the electron is from s orbital, which is spherical in shape, and one of the electron is from px, and one from py, and one from pz, these three orbitals have same energy, but this is not true about the s orbital, which has a little different energy, which is a little different in energy as compared to the orbital. How can the four bonds of carbon be equivalent? So this is a question so far we are leaving for our next. That's how can this be true if the carbon can make four equivalent bonds. How is this true with these four orbitals which are not actually equal in energy? So let's see that in our next lecture. See you, and please do not forget to subscribe my channel, and also turn on the notification for the further videos.